In this video, you will learn how to simplify some radicals. Let's say we're given this radical expression, cube root of 32y to the fifth. We simplify this. We look for factors of 32 that are cube, so we can put it outside of the radical. So 32 can be written as 8 times 4. Then y to the fifth can be written as y to the y cubed times y squared. Because the same basis, we just have to add the exponents from the law of exponents. Then this would become cube root of 8 can be written as 2 cubed times 4 y cubed times y squared. And now we can simplify this. So we can put outside the radical all of the cubes. So cube root of 2 cubed is 2. Cube root of y cubed is y. Then we'll be left with 4y squared inside the radical. So this is our final answer. 2y cube root of 4y squared. Right, what if we're given this one, square root of 16y squared? Well, we can write 16 as 4 squared, because 4 times 4 is 16. So this is square root of 4 squared y squared. Then square root of 4 squared is 4, and square root of y squared is y. Therefore, this one is just equal to 4y. How about this one? Fourth root of 100. So we cannot find any factors of 100 to the fourth. So we can write this radical expression into a rational expression. So we can write this one as 100 to the 1/4. And 100 can be written as 10 squared. So this is just 10 squared to the 1/4. Then by power rule, from the law of exponents, we can just multiply the exponents 2 and 1/4. So that is 10 to the 2/4, and 2/4 can be reduced as 1/2. So this is just 10 to the 1/2, and we can write 10 to the 1/2 as square root of 10. So this is our final answer. How about this one? Fourth root of 7 times 16th root of 7. Now we cannot get the fourth root and 16th root of 7 here. So all we have to do is we write each of the radical expressions into rational expressions. So fourth root of 7 can be written as 7 to the 1/4. Times 16th root of 7 can be written as 7 to the 1/16. By law of exponents, when the terms or the expressions have the same basis, we just copy the base and then we add the exponents if it's multiplication by product rule. So this would become 7 to the 1/4 plus 1/16. So we add 1/4 plus 1/16. Adding fractions with different denominators, we get the LCD, the least common denominator, or the smallest number that can both divide 4 and 16, and that is 16. So 16 divided by 4 is 4, then 4 times 1 is 4, plus 16 divided by 16 is 1, then 1 times 1 is 1. So this is just equal to 5/16. Therefore, we can write this as 7 to the 5/16. Or we can write this in radical form as 16th root of 7 to the 5th. Or we can further simplify this by expanding 7 to the 5th. This is just 16th root of 16,807. So this is our final answer. Right, how about this one? Square root of 3y to the 18th z. So we can write this as 3 y to the 18th. We can write this as y to the 9th squared times z. Then we get the square root of y to the 9th squared. So that is just y to the 9 square root of 3z. So this is our final answer. Right. How about this? Cube root of 27y to the 4th z to the 16th. So 27 here can be written as a cube. That can be written as 3 cube, because 3 times 3 is 9 times 3, 27. And then y to the 4th can be written as y cube times y to the 1. Then z to the 16th can be written as z to the 5th cube, because 5 times 3 is 15 times z to the 1. Right, and then we can simplify this. We can put all of the cubes outside. So cube root of 3 cube is 3. Cube root of y cube is y. Cube root of z to the 5th to the cube root of z to the 5th cube is z to the 5th. Then we're left with yz inside the radical. So this is our final answer, 3yz to the 5th cube root of yz. How about this one? 4th root of x to the 8th y to the 12 over 81. So we can write this as 4th root of x to the 8th. We can write this as x squared to the 4th. Then y to the 12 can be written as y cubed to the 4th over 81 can be written as 3 to the 4th. Then we can simplify this. 4th root of x squared to the 4th is just x squared. 4th root of y cubed to the 4th is just y cubed. Then 4th root of 3 to the 4th is just 3. So this is our final answer. How about this one? Square root of x plus square root of z over square root of x minus square root of z. So in this case, we need to multiply both the numerator and denominator by the conjugate of the denominator. So the denominator here is this one, square root of x minus square root of z, and the conjugate of that is square root of x plus square root of z. So we multiply this by the square root of x plus square root of z over square root of x plus square root of z. Then we can use the FOIL method. FOIL method, we can multiply this. Square root of x times square root of x is square root of x squared. Then this one plus square root of xz. Then this one plus square root of xz. Then that one, square root of z times square root of z is square root of z squared. Then the denominator, square root of x times square root of x is square root of x squared. Then this one minus square root of xz. Then this one square root of x plus square root of xz. Then minus a square root of z squared. And now we can simplify this one. So this cancels out. Then we can add like terms, square root of xz and square root of xz. So this would become square root of x squared is just x plus 2 square root of xz. Square root of z squared is just z over x minus z. So the final answer would just be x plus z plus 2 square root of xz over x minus z. So this is our final answer.